Hello students, welcome back to my channel again. Today we are going to learn class 11's some of the topic of the chapter sets, and this is the fourth session of the chapter sets. So without wasting any time, let's get started. So our first topic is symmetric difference of sets. Symmetric difference of sets. Okay. Let there are two sets A and B. Then A minus B union B minus A. This is called symmetric difference of the sets A and B, and this is denoted as A delta B or B delta A. This is the sign of capital letter. You can say triangle sign. Okay, that means if we represent it by Venn diagram, we will get this type of figure. Suppose this is universal set U, and there are two sets A and B. Then A minus B, I'm just shading it, except the common part. This is A minus B. And this shaded part, again except the common part, this will be B minus A. So its union means A union B minus A intersection B. You can also say like this: A union B minus A intersection B. This is equals to A delta B. Okay. Now symbolically you can say that A delta B equals to X, such that X belongs to A minus B, or X belongs to B minus A. Okay. Our next topic is complement of a set. For this, again I am drawing a rough sketch of Venn diagram U. Suppose this is a set A. Then the set of all those elements which don't belong to the set A is complement of A. That means outside of A. Okay. Inside the universal set but outside of A. That means from the figure I can say that the part except this circular part is the complement of the set A. Okay. So symbolically we can say that, and it is denoted as A complement or A prime. Okay. Or you can write down U minus A, universal set minus A, that is equals to X, such that X belongs to U but X does not belongs to A. Okay. So this is A complement. Like suppose U is 1, 2, 3. A is equals to suppose 1, 2. Then A complement will be 3. Okay. Another thing we can say, therefore A union A complement equals to the whole universal set. A intersection A complement equals to phi because they don't have any common element. And suppose U I'm taking as the set, suppose A equals to U, then U complement equals to phi because U is the whole set. Okay. Coming to its next part, that is properties of complement. Number one property that I already have written, A union A prime or A complement equals to universal set. This is number one property. I am writing it again. And A intersection A complement equals to phi. Then number two property is A union B its complement is equals to A complement intersection B complement. Just this union sign will be changed to intersection. Similarly, if it is of intersection, then it will be complements union of individual complement. Okay, like this. These two laws together, their name is De Morgan's law. De Morgan's law. Okay, these two together are called as De Morgan's law. Number three is double complementation. That means A prime or A complement's complement will be the set itself. Again A. Number four, the laws for empty set and universal set that I already told. Phi complement equals to U and U complement equals to phi. Okay, so these are four properties of complement of sets. Now we will be going towards some practical problems on union and intersection of two sets. Okay, for that reason we need to draw. This is practical problems. Just writing the heading. An universal set and two sets. I'm not taking both same. One is bigger, one is smaller. I'm taking this one as A and this one as B. Quite simple, you all know that this is A minus B. This common part is A intersection B and this part is B minus A, which I already told. From this you can see that if we add, just generally, roughly you tell that if we add these three parts, we will be getting the whole A union B, right? Roughly I am telling. Now there is a term that is N of A. Suppose the set is A, so what is N of A? N of A means number of elements of A. Okay, so suppose A equals to 1, 2, 4, 9. That means how many elements are there? You need to count it. 1, 2, 3, 4. That means N of A equals to 4. Okay, so our first problem regarding this topic is N of A union B is equals to N of A plus N of B minus n of A intersection B. Okay, I think ink has been already. Sorry students, my pen's ink was totally finished. So I'm just continuing with a new pen. I'm repeating it again. N of A union B is equals to n of A plus n of B minus n of A intersection B. Oh my god, this is blue colored pen. Okay, doesn't matter. So we need to prove it. How will you prove it? Okay, first of all, from the Venn diagram, what is that? From the Venn diagram we can see that number of elements in this part plus number of elements in this part plus number of elements in this part is equals to the whole union. So we can write it. We know that n of A union B is equals to n of A minus B plus n of A intersection B plus n of B minus A. Right? Now let it be whatever. I'm just adding n of A intersection B and subtracting n of A intersection B from it. So it is actually balanced now. So now I'm doing like this, n of A minus B plus this together. Okay, intersection B, these together plus n of B minus A and this plus n of A intersection B, these two together. What is left? We are left with n of A intersection B minus n of A intersection B. Now A minus B part and A intersection B part, if we are taking it together, we will be getting the whole set A, isn't it? Look at this, A minus B and A intersection B, if we are adding, we are getting the whole set A. That means this is whole set A's number of elements plus similarly this will be whole set B's number of elements minus n of A intersection B. Look at this, we needed to prove it and we just got it proved, right? So we have got it. Regarding this, we have the second problem, that is n of A union B equals to n of A plus n of B if A intersection B equals to 5. So it's very simple. If you want to do it mathematically, then it can be proved from this problem, that is, if A intersection B equals to 5, that means n of A intersection B is equals to 0, because A intersection B is 5 means it doesn't contain any element, so its number of elements 0. So we are left with the required result, right? Now you can prove it by Venn diagram also. How? Suppose this is U universal set, A and B. They both are disjoint. They don't have any common element. That means it is quite obvious. A union B means this part and this part. Okay. So obviously number of elements in A union B is equals to number of elements in A plus number of elements in B. So it's actually very simple. Now we will do some more results on algebra of sets. Okay. Like number 1 result. These are results. Just give it a heading, results. So number 1, suppose A minus B is equals to A intersection B complement. Number 2, A minus B equals to A implies and implied by A intersection B equals to pi. Number 3, A minus B union B equals to A union B. Number 4, A minus B intersection B equals to phi. Number 5, A subset B implies and implied by B complement subset of A complement. Number 6, A intersection B minus C equals to A intersection B minus A intersection C. Okay. So these are 6 results that you need to prove. You need to verify it. Okay. So this one is straightforward. You can actually do or you can prove all these 6 results by using Venn diagram very easily. Just you need to be very, very careful about your statements that you are going to write. Okay. Those statements must be proper, otherwise whatever you are thinking will not come to your copy. This is easy. This is also very, very easy. This is the super easy. This also. This and this, these two I'll be proving. Now these two, if I'm proving these two, so just means you can say that for its applications, these type of all proving part you can do in the same way. So now just start watching it. So for this one, number 5, that is A subset of B implies and implied by B complement subset of A complement. Now these two results proofs I'm not doing by using Venn diagram, rather I'm doing mathematically, which is logical calculations. Okay, set is actually one type of logic. So firstly, we have this condition, we need to prove it. Okay, so let any element x belongs to B complement. Okay, just let me remind you one thing, that subsets definition, that is if an element belongs to a set and it implies that that element belongs to another set, so the first set will be subset of the second. So if we have taken x belongs to B complement, that means x doesn't belongs to B, right? If x doesn't belongs to B, look, B is the biggest set. Here it is the given condition. This one is the given condition. So B is the biggest set and x is not there in the biggest set. So there is no chance for x to be in A. So we will be writing x doesn't belongs to B. That means that implies x doesn't belongs to A. Now if x doesn't belongs to A, that directly implies x belongs to A complement. Now look, we started with x belongs to B complement, we ended up with x belongs to A complement. That means in this way we can say therefore B complement subset of A complement. Okay, so this is the process that we have just done from this to this. This is the given condition, this we need to prove. Now we will be doing conversely. So converse part is we have this condition, we need to prove it. Okay, so in the same way we will be taking x belongs to A. Let x belongs to A. Okay, now it means x doesn't belongs to A complement. Okay, now we have taken now this as condition. So if an element x doesn't belongs to the bigger set, so it will never belong to the smaller set. So we can say x doesn't belongs to B complement. That means x belongs to B. Now look again, in the same way we started with x belongs to A, we ended up with x belongs to B. That means we can say A subset of B. Understood? So we have proved both the conditions, necessary and sufficient condition. So we have got it proved. Okay. Number 6. We need to prove A intersection B minus C equals to A intersection B minus A intersection C. Now I am telling you one trick and one method, you can say, that whenever you are getting in the middle operation, that is equal sign, then you need to first prove with that first left hand side subset of right hand side, and in the second step you have to prove right hand side is the subset of left hand side. If both are subsets of each other, that means they both are equal. I mean to say, if A is subset of B and B also subset of A, it means A equals to B. Okay, so let's start it. We will always start with the element and the left hand side part. So x belongs to A intersection B minus C. Intersection, that means x belongs to A and x belongs to B minus C, right? Therefore x belongs to A, and for this x belongs to B and x doesn't belongs to C. I am taking these two together, x belongs to A and x belongs to B, and I am repeating it, x belongs to A and x doesn't belongs to C. Okay, implies x belongs to A intersection B and x doesn't belongs to A intersection C, because x is not a common element of A and C. That's why x doesn't belongs to A intersection C. That means x belongs to A intersection B, intersection of A minus, I just wrote it wrong. It will be A intersection B minus A intersection C. Okay, you take this one as suppose the set E and this is suppose set F. Then x belongs to E and x doesn't belongs to F means x belongs to E minus F. Okay, so we started with this and we ended up with this. So we will be writing, therefore A intersection B minus C subset of A intersection B minus A intersection C. Similarly, the opposite part also we can prove in the same way, and that will be your homework. Like number 1, number 2, number 3, number 4. These 4 properties also will be your homework, 4 results, and the second part of this. So similarly we can prove that A intersection B minus A intersection C, subset of A intersection B minus C. So we can say that A intersection B minus C equals to A intersection B minus A intersection C. So we got it proved. Okay. So students, this is all about today's session. I hope you all have understood it. We will meet in the next video with any other topic. Till then, thank you.